Okay, chapter 7, because we are talking about oceans, can't talk about oceans without talking about waves. So 7.2 focuses on waves. Any wave is caused by a disturbance moving forward. So when we talk about ocean waves, some sort of a disturbance causes that water to move. The same wave principles that apply to waves in the ocean are also going to apply to waves elsewhere. So when we think about us up here, think about a lake. When you have waves on the lake, same principles apply. And also, the kind of another cool thing is when you talk about waves in water, this is how waves travel. So even if we're talking about sound waves, it's literally the exact same. So it's kind of a cool thing because you're going to learn about sound at some point here. Just to remember, these things apply to that as well. So waves are caused by a disturbance moving forward. And they occur as a repeating pattern of what we call crests and trough. So this little girl, she has a rope here, and imagine kind of like swinging it up and down. It is creating waves. She is creating a disturbance on one side, but you'll notice there's a pattern. I can see these high parts and these low parts that are being created. The high parts of the wave are called the crest, and then the low parts of the wave are called the trough. Just to go over a few definitions when we are talking about waves, the distance between a wave crest and a trough and the average level of motion is called the wave's amplitude. So think of that. If that same girl were taking that rope and really started putting some energy into it and forcefully moving it up and down, think of what that would do to the wave. Think of how those crests would become much more dramatic and those troughs would become much more dramatic. She would be increasing the amplitude of the wave by putting energy into it. We also use a term called wavelength to measure the length of a complete wave. When you do this, make sure you always pick one point to another. So if I look at this picture, it looks like they're doing the beginning of one wave to the beginning of the next. You could do something else if you wanted to do crest to crest, trough to trough. Just make sure you pick whatever it is. So those are really important terms when we look at waves. So we have a wavelength, we have amplitude, crest are the high parts of the wave, and then trough are the low parts of the wave. The time it takes for one wavelength to pass by a single point is called a period. So now imagine taking that wavelength, and if it's coming by more quickly, you're going to be increasing the period of the wave. And think about what would happen. What scenario would have to happen for that to occur? She's going to once again have to put more energy into that rope to get it to be those crests coming quicker, those wavelengths coming quicker. When waves move through water, they actually cause a circular motion in water as they pass by. It's kind of weird to think of, but imagine being on an inner tube and you're floating on a wave. It feels to you like you're going up and down, but you're actually in all reality moving in a circular motion. Another thing your book talks about, as you can see on the right-hand side here, is that wave motion decreases the further down in the water you go. So if you're floating on that inner tube on the top, it's going to be the most dramatic effect of that circular motion. Let's say you jumped off the inner tube and you dive down below, there would be a point at which you're not going to experience that wave anymore. And that's actually called the wave base. I'm going to show you a picture here in a second of what that is. If I were to compare a seagull and a dolphin, seagull's up on the top of the water, dolphin's on the bottom, ask yourself which one is going to experience the wave motion greater. Should be the seagull, right? So seagull's up on top, more dramatic effect. Here's another picture just showing us adding some arrows to it. So yes, that seagull on top, much more dramatic circular motion. You'll notice the farther down you go in the water there, the less it gets to the point eventually when you're not going to reach any circular motion or experience any circular motion, and that would be the wave base. Most ocean waves are caused by friction between wind and the ocean surface. So imagine wind pushing over water. As it pushes over water, creates friction, causes water to move. That would be one of the reasons why ocean waves occur. Now, when I look at what depends on the size of the ocean waves then, because we know that we have waves that are bigger and we have waves that are smaller, it is these three factors that affect ocean waves. Wind speed, so how fast the wind is blowing. The faster the wind, the stronger the waves. How much time has the wind been blowing for? Wind blowing for 4 hours is going to produce a larger wave than wind blowing for just an hour. Finally, the last one is a word we're not so familiar with, but maybe when you can think about, let's say you like to fish, and let's say you go on a really big lake compared to a small lake. You may have noticed on a larger lake, so let's even take Lake Superior, for example, you're going to have a tendency to get much larger waves than if you went on a small lake around here, and that is called fetch. So the amount of open water over which wind blows is the wave's fetch. So all three of those factors, wind speed, length of time that the wind blows, and then fetch, are all going to affect the size of ocean waves. We use the Beaufort wind scale to set a number to, or set a rating to, on wind speed. It goes from 1 to 12. The higher the number, the greater the wind speed. And you can also correlate that with damage, obviously. So the higher you are in the Beaufort wind scale, the more likely you are to have damage to property. A couple other terms we talk about in terms of oceans. Storms can produce waves. Obviously, we all know that, right? When you talk about the types of waves a storm can produce, when you're near the center of that storm, it produces short wavelengths. So really choppy water. As those waves move outwards, they get much longer wavelengths, and we call those swells. So long, fast-moving waves, those are the ones that move away from the storm. If you see anything like this, this is called a wave train. So when waves travel together, that is called a wave train. Kind of makes sense, right? Just to note that waves can affect each other. So when waves form in different places, come together, they can add to or subtract from each other. So let's say you have two medium crests come together, it can form a large crest. If I have two medium troughs that came together, they'd form a large trough. But interestingly enough, if I have a high and a low come together, so a crest and a trough, they will actually cancel each other out. Finally, can't talk about ocean waves without talking about the largest ocean waves on Earth, and that is tsunamis, or are tsunamis. A huge wave may be a large disturbance. It can be a variety of things. Underwater earthquake. So if Earth's tectonic plates move, it's enough to create a disturbance. Underwater causes that water to forcefully create a disturbance, and then you're going to get a tsunami. A landslide. So just like when you take a rock and you drop it in a pond, now imagine nature doing that with a really large rock, a really large chunk of land, or a volcanic eruption. Actually, the largest tsunami on record, which is around 1,700 feet, was caused by a landslide, and it actually happened in Alaska. Crazy large tsunami. So the wavelength of a tsunami is much longer than a wind-driven wave, as you can see in the picture here, much longer. One of the characteristics of a tsunami is when they occur, they pull the water out from the beach. So the bad thing is this happens, so a natural human tendency would be, hey, what's going on here? Let's go out here and check. While you're going out there to look at things, little do you know, you have this huge water surge that's going to be coming up. And that's really where the danger comes in from tsunamis, is water is very powerful. So besides the fact that water is powerful, now it's pushing all of this debris, wood, metal, all of these other things. If you were in that surge, you can't just say, hey, I'm going to like easily ride it out, because you are going to be forcefully pushed along with all of that debris, which is not good. The most deadly tsunami on record didn't happen that long ago. So December 26, 2004, the Indian Ocean tsunami was triggered by a 9.3 magnitude earthquake, very large earthquake by any standard. It killed approximately 300,000 people. Like I said, is the deadliest tsunami ever on record. Here's just kind of a picture showing after that water goes out. The locations on this map that are in that sort of mustard yellow color there, those are all of the locations that people died from in that Indian Ocean tsunami. The gray circles are where the earthquake originated at. So you can see that's actually where we had the most loss of life, but they experienced loss of life even further away from there. It's a really bad time of year for it to happen. It was when Europeans are vacationing. So a lot of Europeans will go vacation in those locations. So that made it horrible. You're also talking about a lot of locations where you have third world countries. And so you have not the structures like we have in our country. We're not talking about brick and mortar homes. So you can start to see really why you have much more devastating effects. And then also after the fact, even after the water recedes, you have a lot of things that can happen to human life, human impact after that can also cause devastation.